For this lab, we will focus our attention on validating vulnerabilities that were previously discovered using OpenVAS. The validation of the vulnerabilities will be done through the use of the Metasploit framework. The Metasploit framework has a number of different interfaces. The most commonly used interface, especially for beginner users, is Armitage. So we will be using Armitage as our platform to help us kind of go over the methodology of consolidating, importing vulnerabilities into this framework, checking for the existence of known exploits based on the imported vulnerabilities, launching the exploits against our predefined metasploitable target, and then being able to interact with the target using the exploits by means of an actual shell access or meterpreter. Meterpreter is an advanced interpreter that allows us functionality like communication with the remote system. It's more advanced than the actual shell, allows us for some additional functionality like dumping hashes, pivoting from one process to another, and so on. So to get things started, I wrote a brief, what I think is a brief, of course, lesson plan. So before we go any further, we need to make sure that you're saving a snapshot of your Kali instance as well as Metasploitable. And the reason for that is during the exploitation process, we can run into different errors, either on the Kali or the Metasploitable, as a result of overtaxing resources, and it will be very critical to be able to restore to from a known good state to kind of continue our effort as opposed to start over. So make sure you do a snapshot actually of your virtual machines, and you go to machine, take a snapshot, go ahead and label it, and then click OK, and do the same thing for your Metasploitable. Again, machine, take a snapshot. Something else to consider is making sure that the two virtual machines can talk to each other. So for the settings, go to your network setting, make sure the attached to is host only adapter. The same thing for Kali. Make sure that you have a machine settings, go to your network and host only adapter. Something else you need to do is make sure that you ping the different hosts between each other. So go from the Kali and ping the Metasploitable VM, which for me is IP address ending in 101. And I see that I have responses, which means communication from Kali to the target is successful. Now I'll do the same test from Metasploitable to Kali, and when I did this test, you can see here. So you can see here that I have ping my IP address ending 102, and then I have the actual responses from the Kali VM. So once you do that, what we need to do is caution you. Do not update your Kali environment. If you do, I notice that it can break Armitage. And I walked through the process. I provided some direction in what to do if your Kali VM gets to an unstable state and you need to rebuild. And I also provided some directions on how to rebuild Armitage if you're experiencing some responsiveness issues and error messages. So let's see, in order to get things started, in order to start the Metasploit framework, we need to actually start the database service and then initiate the database. So we'll do this from the Kali terminal. We will go into start the Postgres SQL database. Now I already have it started, and then msfdb init to initiate the Metasploit framework database. So it's already initiated. Now, once I complete these two commands, what I need to do is start Armitage. And Armitage, we can be started from the quick launch on the left hand side. So you left click on the Armitage icon. You can type Armitage in the terminal, or you can also go to the applications. Let's see, go into the exploitation tools, and there should be, there we go, an actual shortcut for Armitage. It's kind of nice in here because the different tools are organized by their purpose. Now I have to caution you, this video is going to be probably long because there's going to be a number of things we need to do, a number of vulnerabilities we need to validate and exploit. I'll try to be as succinct as I possibly can. So let's get Armitage. What we need to do is I'll walk you through kind of what Armitage looks like, the general purpose. So we need to click on Connect, leave the default settings, and then click Yes to start the RPC handler. We're going to wait for this process to initialize. Now the other thing you need to do is make sure that you have an OpenVAS exported report in NBE format. It will be also helpful to have your Nmap XML result, and for Nmap we need to make sure that we have all TCP ports scanned. Since I don't have an XML Nmap file saved, I'll show you how you can do this from within Armitage. So the first thing we see is that we need to specify the IP address for our Kali, which in my case is 56.102. So I click OK. A very quick run through Armitage. What you have in front of you is the modules pane, and this is the work pane, and this is the actual console. The console is going to be our command line interface for specifying different options, getting help, as well as using it to tell Armitage what to do for behind-the-scene operations. A lot of the functionality can be used through a point and click, but the console provides that additional level of essentially control and being able to manage the configuration as well as the results from the different activities performed in Armitage. So what we have on the left hand side is the modules menu, the auxiliary. Those are typically scanners for information gathering, for system discovery, service discovery, and so on. The exploit is the actual instruction on how to take advantage of a known vulnerability. The payload typically is how we interact with the target. So that could be through a reversed shell or bind shell, or interpreter connection, or HTTP connection, or Java, or any other type of interface. And they're kind of varying based on the nature. It could be a Python script, it could be a PHP, and so on. So the other available module is the post-exploitation, and they include things like persistence, pivoting, being able to elevate privileges, and so on. So the different modules are organized in a logical scanner and in a logical organization. So for the exploits, you're using them by operating systems. So you go Linux, OS X, Unix, Windows, and so on. And then what happens is we can continue drill. So Linux, then you have the service. From the service we select FTP, and then you have the actual application. Okay. In the little search menu here, what we can do is we can look for a particular service. So I typed in VSFTPD, and if you notice here, I have an exploit that's related to VSFTPD. If I would like to find more information about the exploit, I double click on it, and then in here I can see brief description, and I can see different options that I need to specify in order to be able to launch the exploit against the specified target. Some of these parameters: lhost is localhost, lport is the local port we'll be using. Your local host is your Cali. Okay, this is the IP for Cali. So if this is not pre-populated, you need to make sure the local host is always pointing to your Cali IP address. The local port typically is insignificant as long as it's a port that is not already in use. The remote host is target, so remote host equals target. The remote port is 21. Obviously, if VSFTPD is using a non-standard port, like 2121 for example, we need to make sure that we double-click and specify 2121. And then you can use the target. So in our case, we're not going to do automatic. Automatic is if you have a number of targets here, it's going to launch against all targets. We need to make sure that we're precise. We're only targeting the system that's in scope of our assessment. If you go out of scope, that could be a violation of the rule of engagement and substantially cause breach in contract and some legal actions against the tester. When we're looking into the advanced options, some exploits will have additional configuration, and they're available in here. And then in order to launch the exploit, we can click launch. Now the same operation can be done from the command line. So what we can do is, if we type in help, we can see a help menu, and we can see some of the basic functions and commands that are available. Okay, so to get things started with the Metasploit framework, we obviously need to import a target. Once we import a target, if we just launch an exploit, it may not be successful. So to help Metasploit better match the target with an open port existing vulnerability, and then match the known exploit for ultimate likelihood of success of the actual exploit and establishing a connection, we need to import some information into Metasploit. Metasploit itself is not a vulnerability scanner. It does have integration with Nmap, and through that we can obviously have the same functionality as actual Nmap, but it does not provide vulnerability scanning functionality like OpenVAS. We can connect OpenVAS and conduct a scan from within Metasploit, and I will upload a different video on how to do that. Or if you're interested, make sure you contact me. What we can do here is we can do a database connect, and then we need to connect to the OpenVAS database. We need to provide the username and password, obviously the IP address for the OpenVAS interface, and then from there we can use the command line interface to set up a new scan, the parameters of the scan, and launch the scan directly from the command line of the Metasploit interface, in this case the Armitage console here. We can also do the same thing for another vulnerability scanner like Nessus or Nexpose. From the free version, this is the community version of Armitage. A lot of the configuration is manual and through the command line. Once you go into the enterprise commercial grade products, they allow for easier integration and mostly using the graphical user interface. So in here, if you noticed, what we can do is we can do a database import. The database import is where we can actually import an existing vulnerability scan report from OpenVAS. And I mentioned at the beginning, you need to make sure you have your OpenVAS report in NBE format. NBE format. Okay. So once you have that, we have a couple options for let's see what happened here. It looks like I have a number of interfaces. There we go. So we can use the db import, and then we need to tell the location of the file I need to import. In here, so I do a db import, and then I just specify the file I need to import into the database. Okay, and then I hit enter, it's going to import it. Or I'll show you a different way. If you go into import hosts, use the GUI method, and you specify the location where you save the OpenVAS report. Click open. Okay, so now we see that we have our Metasploitable target. If you notice here, we have a computer, but the operating system is not showing up. So the OpenVAS report is great. It provided some background information, but also will be very, very helpful if we import an actual Nmap XML file. We make sure we scanned using the Nmap script engine, as well as we scanned all TCP and UDP ports. Since I don't have an XML Nmap file, I'm going to do that directly from the Armitage interface. I'm going to go into hosts, Nmap scan. We will go ahead and we're going to do intent scan using all TCP ports. So I'm going to do that. I need to specify the target. Make sure your target IP is correct and click OK. Open up a new tab, and if you noticed, from here we have the db nmap command. We're saying that we want to scan all ports 1 through 65,535. We're going to use relatively fast scan with Nmap script engine, version detection, operating system detection, verbosity enabled, and then we specify the target. Then what we see here is we have a lot of open ports discovered. Okay, so it's doing a service scan. Once this is completed, we'll be able to actually get an identifier for our target. And I'm going to go ahead and pause the video because that's going to take some time. So with actually the nmaps completed, what we're gonna see is the scan complete. So the next step is once now we see that we have this little penguin indicating the logo for a Linux-based operating system. Now, what we will notice is we need to go to attacks and find appropriate attacks based on the information that was discovered. So now what we're doing is with finding attacks, we have done an nmap scan. There's going to show us open ports, running services, their versions. We have an OpenVAS vulnerability scan report imported. And what we can do is find relevant attacks. Now, if we were to come in and we can use the graphical user interface to find some information about the vulnerabilities that we imported. Okay, and to do that, what we can do is use the console, and then from the console, what we can do is leverage the help menu. So we see in here that we have vulns is going to list all vulnerabilities in the database. Okay, so let's see. If we do vulns, so we see they have a number of vulnerabilities, but obviously this is not, really readable. Okay, what we're going to do is we're going to do vulns. We're going to do ash, capital dash S, and actually the way I know is vulns, and I need to find out, well, this is the vulnerabilities command. I got it from the main help menu, but how do I use this command? I type in space-h for help, and then it tells me some additional options. And the beautiful thing is also provide some examples. So if I do vulns for port 1 through 65,536, is going to show me vulnerabilities for this port. If I also do lowercase s, it tells me, this is service HTTP. Now, the difference with the lowercase s is a service. Uppercase s is a search for a particular string. So vulns -s vs ftp d. Okay, so I see that I have one vulnerability that matches the string vs ftpd, but again, this doesn't mean a whole lot to me. I see that the host is 101. I see that the time that it was obviously imported. I see the NSS name and then the reference. So if I go in and look into the OpenVAS reference number, I probably can get some information. But this is not very user friendly for me. So then what I do is I want to find out information about this particular vulnerability. Okay, so what I did then is I used the -i. -i is information. How did I come up with -i? I looked up that in here -i is display vulnerability information. Okay, so I see that the vulnerability is VSTPD is prone to a backdoor vulnerability that's based on, again, the imported OpenVAS vulnerability report. Attackers can exploit this issue. Solution, well, there's a vendor fix, obviously. Affected software, this is the actual version. It tells me about the detection method, details. It tells me the CVSS score, which is 7.5. According to CVSS version 3, this is rated as a high severity. If you look into, it gives me a version 2 score, which is still high. Critical is 9 to 10. I see that there is additional reference ID, and there is the actual reference where this vulnerability was reported. There's actually a number of them. So let's see that I would like to find out all vulnerabilities that are related to IRC, and there is nothing in there. What if I do capital? What if I do like this? there's no vulnerabilities found like this? Well, if we really look through these vulnerabilities, we'll find out that there are. So what we have to make sure is the syntax. If you look into, obviously there's two vulnerabilities. It's how we actually go in and use the syntax. It's an actual match, and what we have to do is look for the string that is likely to trigger a result. Okay. What we will do in from here is we're going to leverage a very rude way of validating low-hanging fruit vulnerabilities, and that's using the built-in Hail Mary functionality of Armitage. What Hail Mary does is it looks into the open ports, discovered vulnerabilities from OpenVAS. It matches them against known exploits in the Armitage Metasploit backend database, and then launches them to validate if they are actually relevant or not. Now, Armitage is going to cover some low-hanging fruits. The disadvantage of Armitage is very noisy, and it can also cause overtaxation of resources, so system instability. A great way to do quick and dirty assessment, but it's not thorough, it's not ultimate, it's not replacement for doing a thorough job of going through every single open port service and going down the list. So we'll start with Hail Mary, and then this is going to cover some foundation, and then we're going to go in and fill in the blank where Hail Mary failed. Okay, so we did find attacks. So we found relevant attacks based on the open ports and imported OpenVAS vulnerabilities. The next step is we're going to do the Hail Mary. So once started, Hail Mary will launch. Make sure that you're only launching against systems in scope. It's asking us if you want to verify. We click yes. So now what it's doing is, again, matching the open port, the running service, the version, the known vulnerability with the repository of known exploits. Now these are only publicly available exploits. If you're going in using the commercial version, you're going to see some additional features. You're not going to see all the exploits in here. This is the public version, if you will. So obviously this is going to take some time. If your Metasploitable system ceases to work during this process, what you need to make sure is that you restore from a snapshot and start the process all over. You're not going to be able to pick up. Sometimes you may be able to reboot, but as soon as you reboot, any shells that you establish are going to be gone. So you have to repeat the process. So if you're looking into it now, it's going through iteration. You're seeing to web application vulnerabilities. He's looking through them, and he's doing a lot of guesses. And this guesswork is what can overwhelm the target and cause it to seize the service, or hold the system itself. Sometimes you're going to get only one chance to be able to validate a particular vulnerability. After this, the service may cease to work. So it's very important to make sure that during the process you're taking your screenshots and doing your due diligence. As I mentioned, one time to validate an actual vulnerability and take advantage of it. So it's important that when you get a shell, make sure you do a full screenshot with your date and time, and then you're presenting that at this day, at this time, based on these conditions, I was able to validate the vulnerability. Now, if somebody fixes it, 5 minutes after, well, you still need to report it. You've done your due diligence. They've, fixed it after the fact. So once all the guessing is done, what's going to happen is you're going to have a number of sessions listed. Sessions are actually established connections with the target. Each session presents a communication channel. And the more communication channels you have, the more the chance that we have persist connection. Once the target was successfully exploited, it's going to have these lightning bolts. And in here we can see that we have 1, 2, 3, 4, 5, 6 successful shells. Shell indicates shell access, so it's going to be essentially a remote terminal connection to the target. Shell can be upgraded to an interpreter connection, okay? And if you're looking into, we can do interact to actually start to interact with it. It's obviously we have a number of logins. We can look into the logins, and we see FTP. So it looks like we already were guessed admin for FTP accounts. So we have those accounts here. As part of the discovery also, there was MySQL, and it looks like, look at this, admin for MySQL connection. Maybe the same thing for the Postgres SQL database. It looks like the same thing maybe for FTP or Telnet. We will validate those. So we had the Hail Mary process helping us spawn some shells, and let's review what those are. So the active sessions are listed here. They're listed by unique ID. It tells me what type of shell. It's a shell and based on PHP. Let's see, it's a tunnel connection from our attacker on this port direction to our target on this port, and then it tells us via the actual exploit. So this is the portion where you need to record, because once you've validated an exploit and this was obviously successful, what we need to make sure is we demonstrate how we got this exploit, which exploit did we use, and this is the actual portion that will help you. This case was through the HTTP service, and it looks like it was PHP vulnerability. Is it encrypted? No. And let's see what else. We have another. So this is a Unix vulnerability, and it looks like it was another shell. It's telling us that it was on port 6200, and it was leveraging the VS-FTPD 234 backdoor. So this version of FTP was vulnerable, and we spawned a shell using a publicly available exploit. Next, we see that we have the Postgres SQL database, and there's a connection spawned through that. Another shell connection. We see that we have the Samba service user map script vulnerability, and that's on some random port, and that was taken advantage of. We also see that there was another one, so it looks like there is a number of Samba ports. So if you look in here, this is our nmap scan. If we look for Samba, we can see where we have the actual service. So Mount D, and these are, let's see, the 139s. There you go, 139 and 445. So right there, we see that we have two ports. So port 139 with the Samba, and then 445. Well, both of them, it looks like, have different version, 3x to 4x, and this is 3020 Debian. So both versions are vulnerable, and as a result, what happens is we spawn a shell on each version. So you had two different versions of Samba running to different ports, and we took advantage of both of them. And then let's see what is the last one. This CC exec. So the CC exec service, which, let's look in for the service and see where this service was spawned. It's right there. Okay, so we see that this CCD is 3632, and obviously it was using an outdated version, which was vulnerable and allowed us to spawn a shell. We also see the Postgres SQL, which was vulnerable, and what we can do is, we wonder what kind of, what was the actual exploit? What does it mean? Well, we can, let's say the Postgres payload. So go in here, and say payload. Okay. So I see that the location of the actual payload is exploit Linux, Postgres payload. So there's the same version for Windows. Double click on it, and here I can actually read the description and understand how this was taken advantage of. So default Linux installation. Okay. Share libraries, allowing execution of arbitrary code, and so on. Okay. So that's how this vulnerability was achieved. Now, if you look into, these are only 6 shells, and there's more services than that. So what we need to do is go through the list now and start validating. So we see obviously we have anonymous FTP. Okay, so let's go in and look for anonymous FTP. We have the auxiliary scanner. Okay, we double click on it, and let's validate that it's anonymous FTP. So we're gonna make sure that FTP path, that's the default, FTP is anonymous, and this can be actually anything. And then remote host 101, the remote port is 21. So what do? How many threads, how many instances of checking you want to do? 24 at a time. Sure. And then let's see what happens here. See the little plus, validated, auxiliary remote scanned, and we were able to anonymous read. So we have read access. So if you look in here, and we have attack FTP. Let's see, we already took advantage of this, but for login FTP, now this additional login, showed up. And if we go launch, starting FTP login successful. Great. So that's how we were able to establish a connection. So we know that we have anonymous FTP, and we can read any uploaded files to the anonymous FTP. Perhaps we can test if we can upload files, and we can upload a backdoor or something like that. So now that we went through the Nmap, we validated the 21, we can go down the road. So we have SSH. Alright, so for SSH, we can type in SSH, and there's different type of scanners. What we can do anytime you have a login, you can do login, SSH login. So if we look into that particular vulnerability, okay, so blank passwords, brute force speed, password file, I think we probably have to specify a custom dictionary, remote host, we're going to specify this 1. So now what we're doing is we're configuring, we're going to try to brute force the username password. And again, you may be able to be successful in that depending on how good your dictionary is. We're just going to kind of go in and demonstrate. So can be blank, so we need to specify credentials. Okay, if you have an error message, you'll be able to see that. Let's see, double click to come to the menu. Let's see, we need reconfigure the actual exploit here. Blank passwords, we can tell it VS1. Password file. If you click data, word lists, and now we gotta find a relatively short word list. password list. Let's do the root user pass, SSH. This prompt may or may not work. So there's other ones. Tomcat specific. I'm going to try with this one. Okay. Password file is this. Now we may be asked to provide a user file. We're going to do the same thing. Go into word lists. And we can click launch. So now it's going to try to go through the iteration. So it's going to try root Cisco until we get locked out. So it's going to probably take some time. And if there's a successful match, then what we'll do is it's going to provide a success. Again, there's no guarantee. And if you have some intrusion detection and prevention, this attempt may be blocked. But if you don't, then hey, it's just a matter of time and how strong your dictionary is. So now we kind of went through the nmap. If it's using keys, so we can use this type of attack. We can see if we can get the key. Sometime you can have a share. So obviously we have access to the system itself. And if you were to leverage and demonstrate the insecure configuration of the SSH keys, we can probably download the key, crack the key using another exploit and demonstrate this. So we validated 22. On 23 we have a telnet connection. We see that telnet is open. Okay, telnet is open. Let's see, in here I provided some instructions on how to use a particular exploit. It looks like to crack the SSH key. And I'll figure out how actually I came up to get this key. It's likely it was there's an NFS share, and the NFS share probably had the private key saved. So telnet. Okay, so we have port 23 and we have telnet. Let's go into, while this is still going, console. We can invoke the telnet command from here, 192.168.56.101. Boom. So what happened is telnet is a plaintext protocol, and it looks like it was configured for anyone that connects to telnet. Gets it looks like, look at this, never expose this VM to untrusted network contact. Log in with MSF admin to get started. How fun. So now I have MSF admin. I have credentials. So let's see here. Log in, telnet. Let's do MSF admin, launch. Login successful. So now look at this, session 7 opened. So because this was a successful exploit, we can interact with it. You have another session opened. Fun. Now what if I go into the login and actually try to log in with SSH? MSF admin. Account credential reuse is very common. So MSF admin. And look at this, successful. And what happened here? Session 8 opened. So account reuse. Now going down the list, we saw that, let's see here, with the nmap scan, we went to port 23. Then we have postfix SMTP vulnerability. Postfix. Okay, it looks like it's, let's see what information we can deduce from here. Postfix 25. We can try an exploit and kind of validate an exploit GLD postfix. I don't know if this applies. This is the actual daemon for it. Port 2525. Well, for us is just 25. The remote host is the target, 192.168.56.101. And the target is Red Hat. Well, it's not Red Hat, so it may not be successful, but we can give it a try. If it didn't succeed, well, maybe I should have read and see what this actually required. So bind handler is started, so you may be waiting for a callback. Phone home. Okay, so this module exploits the static buffer overflow. Show advanced. Local port. And it looks like that's everything that's available. So it looks like it's the bind handler is activated. So if this particular module daemon service for postfix was enabled, whenever it's invoked, we may be able to spawn a shell, but that's kind of a long shot. So we are not able to really validate this unless particular condition is met. So let's see, that was 25. We're going down the list. We see the port 53 DNS is open. Version bind, so we can look for any bind. So bind. Bind. So we look into exploit, and this is obviously payload. We're looking for an actual exploit for bind. DNS. Let's see, DNS bind. So there's two. Sends a malformed T-key query which exploits an error in handling. So we can give it a try. 68.56.101 and see if this may be successful. If you notice, every new task shows up in here, and it looks like we weren't able to get anything. Let's try the tsig. 192.168.56.101. Make sure sometimes our configuration needs to be correct in order for this to work. A long shot. Okay, so that's kind of the methodology. We go through every single port and service, and we look into and try to validate. Now there's some, obviously on port 80 we had an outdated version of PHP. We're going to go to some other low-hanging fruits. Let's see, we validated, we did the vulnerabilities here, we did the search, automate discovery, sessions. One thing I needed to show, and I didn't, was sessions. With the sessions you have different options. So what I typed is, I typed sessions and -h, okay. Let's see, sessions -h. From there I have different options. So I can terminate a session, I can use -out to list a session, or I can use -V to list the session in verbose mode. Now, when you list a session, it's going to be kind of, well, that's helpful. It gives me the overall number, but it doesn't give me specific information about, what particular exploit this was. Well, in a nutshell, it's PHP, but okay, that's kind of interesting. And I see that I had the telnet, I see the, SSH using MSF admin, but if I use sessions -V, look at this. Now it tells me more detailed information about each. So sessions -H is the help. And then -I allows me to interact. So the interact is, if you go in here, it's the same thing as this. Okay. Now, let's see. That was the sessions. It's good to make myself a reminder because, this is certainly can become overwhelming. It's good to have kind of your guiding, which is the nmap. Use it as a comparison. Go line item by line item. Maybe put it into a spreadsheet and make sure you cross off so you can keep track of your progress. And this is the same lesson learned for videos that I do. Is I gotta have something to help me guide, otherwise I can go in circles. So the next service we're gonna validate is the remote login service. So what we're gonna do here is we can open up a terminal. I don't know if the R login service is available directly from the Armitage interface, but we can give it a try. No, because I'm not getting the output that I was looking for. So let's open up terminal. Now if I go ahead and close this particular window, I'm going to kill Armitage if I started Armitage from the command line. So make sure you open up a different one. Then RSH 192.168.56.101. So if I go like this, it's going to be, I'm going to be asked for username and password. And the interesting thing here is, look at this. So I'm trying to log in with root. Why root? Because root is the default username I have here. Okay, so I don't have a password. No. Obviously I need public key or password. Okay, so what do I do next? Well, let's go ahead and see if we can brute force it. We're gonna ask Armitage for some assistance. Did I close it? Let's see, good. I minimized it, and where did it go? There we go. So, you're gonna do now it's possible that your computer, just like mine, with 2 VMs, it's starting to overheat. So you may have to restart your Armitage session. It's starting to misbehave here. I'm going to close this instance. Yeah, so make sure you do your screenshots. So look what happened here. Armitage became unresponsive. You see how my cursor is blinking? So if I may not be able to exit it out. I think it's time for my computer to actually get some rest. So what happens here? Did we lose all the work? Well, we hopefully made some screenshots, but I'll show you how you can go look up into the logs and be able to kind of pick up where you left off as much as possible. Obviously, you're not going to have the shells; they disappear. 192, 168, 56, 102. My target should be able to be back here. There it is. Obviously the shells are gone, but look at this. View. Reporting activity logs. So in here, I'm going to see this icon. And I see my activity logs. Look by date, localhost. Look at this. Exploit log. I launched a particular, exploit, and let's see. This was the actual command for launching the postfix port 25 SMTP exploit that didn't work successfully. In here, if you notice, look at this. It actually tells you the syntax for the command that we executed by using the GUI. With this, we are starting the target, then we're setting the payload, then we're setting the localhost. All of this can be done obviously through the command line, and then to run it, we either use run or exploit. Okay. So there's the part of the log that we have that we executed, but that's not everything, right? So here's the rest of the stuff. Obviously, we use the auxiliary scanner, and we use the FTP anonymous scanner. So in here we see this. See, this was successful. Look at this, login successful. Okay, so that was successful. Also, we saw that we did some password cracking, and obviously that interrupted. We see that those are the different iterations that were tried. So it's not comprehensive, but better than nothing, right? So these are all the commands that we executed in the console itself, right? All the different shells that we have. So that kind of helps us, with what was successful or not. Here, don't we have anything? The Hail Mary, obviously we use that. So there should be, here's the output of that command and different shells that were spawned. We have the import. So we have a record that here's the file that we imported, NBE. So maybe we need to, if we need to re-import again. Here's the nmap. Okay, because we launched nmap. And here's all the results from the nmap scan. So now we can pick up almost where we left off. Okay. So let's see. Going down the list, we were looking for the R login. Okay. And if this would allow me. Let's see. We are looking for R login. R. My computer may really need to take a break. It looks like the fan is getting hot. Or the CPU is getting hot, so the fan is working extra hard. And my Armitage is gonna not cooperate again. R login. And let's see, auxiliary scanner right there. This is the one we're gonna use for R login service. So notice here, what we need to do is from user file. I don't think we need this. Of course, you can try with it. You can try without. Let's see. We discovered that password is going to be anything. Remote host. That's going to be our target. 192.168.56.101 RSH services. Now, if I go into view reporting activity logs, I don't know if I close that, but I go O and I need to pull that up. So make sure that I keep that up. I'm looking for the R login for these remote services. There were a number of them. They were looking here. All these are 512, 513, 514. All these are R login services. RSHD, RSH, R login D. So what we're going to do here with our exploit where did it go? I clicked away and it disappeared. Oh, there it is. So we need to configure the port. So we're going to start with port 512 and stop on success. Sure. So what we're doing is brute forcing. So this module will test the R login service on a range of machines and report successful login. Okay. So let's give it a whirl and go back to the interface. I launched it, but I don't see where I launched it, so let's do it again. If I launched it successfully, I'm going to see a new tab to open. Oh, it looks like I did, but it has some delay. And it's starting and it completed. But that's not the result that I expected. So let's see. Double click to remove its context. Make sure the option is blank. Oh, username root. So I needed to specify the username root. So for, how would you know these? Trial and error. So I need to make sure that this is blank. I need to make sure that the port is 512. My destination is 190.168.56.101. And I am looking for my username root to help it out. We can try some other common ones. Guest, administrator, admin, and there you go. Now it's working. We specify the root from root. So log in. We see that we have this successful account. So root, and we'll be able to log in. So RSH, let's see if we go into terminal. RSH 192.168.56.101. Oh, that's actually blank password. R login root from root. Let's try the same one with a different port. At this point, I double clicked on here. And let's see. From user password file, it looks like my target is there. Stop on success. We're going to do 1. And we're going to try to use the username. root. Use the port 513. Now look at this. So the first one on 512 did not work successfully. Okay. This one did. Root with no password. Okay, so this one, when it was successful, open the shell session. So what we can do for the first one, we go back and we can try to leave the dictionary file in place. It's going to go through the iteration. If it finds a matching password, it's going to, obviously crack another shell open. So we do the same thing for the 514. Now, there's something different for 514, I think I found out. Actually, no, it's a different port. 514, so you do the same concept as we did here. Let's see, double click. Maybe this time we can, from user file, we're going to remove, so we're going to remove that. We have, we're going to try default user, like the user root. We're going to change the port to 4. We're going to change stop on success so it doesn't run anymore. And we're going to provide username root and see what the result is. And it attempted, but it didn't spawn a shell. Okay, so the only success was on port 513. Okay, so the next thing, another low-hanging fruit is 1524. 1524. Look at this root shell. So anybody that connects to this will be able to do root shell. So let's go and test it out. Telnet 192.168.56.101.1524. Now look at this. We're able to successfully connect. So what we can do is, if we go into terminal, telnet 192.168.56.101.1524. Look at this. Who am I? Root. So that was a backdoor on 1524 that was advertised. So this was relatively easy. So next, IRCD exploits. IRCD. And there is IRCD. So let's look in here. IRCD. IRCD. Control F. IRC. Look at this. So I did Control F to open up the find, and I have two services, 6667, 6697, using the IRCD. IRCD. And look this. There's a backdoor. And the remote host 192.168.56.101. Give it a world. So it's predefined the local host, which is our attacker, the remote port, the remote host. And what's happening here? It's actually working on it. Using IP address instead, sending the backdoor command. If successful, it's going to spawn a new shell. Now, it is possible that the target actually crashed and it's not going to be successful. It looks like in my previous demo, it was successful and it was working just fine. So what we need to do is, validate. It looks like be patient. So session 2 was opened. So just be patient. Let the magic work. Okay, and we can do the same thing using port. Let's see, what is this? Using port 6697. 6697. Double click. 42697 and launch, and this should after some time validate. The next thing we can try is, it looks like MySQL. We can brute force the MySQL. So we see the 3306 is open. Three three zero six 3306. Yep, we see that there's a vulnerable version. So obviously we can try to launch an exploit against the vulnerable version. Or what we can do is we can try to brute force the account. We saw, let's see, if we go into login, MySQL, we have a number of accounts. Let's do root, because what we were able to do here was root with a blank password and try. Nope. Login, MySQL. Let's do root. Can be blank. Let's do root. Wild guess. Incorrect. Access denied. Using password. Yes. So obviously not good try, but sometimes you can get lucky. So what we need to do is you can actually go in, and it looks like I've done this with MySQL brute force module. MySQL brute. Okay, MySQL login. So let's see into the configuration that I worked out. Okay, so what we need is set user file. So the user file is word list Unix users. How about that? Unix users, and then let's see, user as pass1, user as password. So essentially using the same user file, dictionary file for username and password. User as pass equals 1. Save us some time. Alright, and you should have 2 results. Let's see. And I think I didn't set something up correctly, because I'm expecting to have a using password. Yes. Let's see, maybe relaunch it. There must be an option that says on success, stop on success. Yes. 2386 remote host. Unix users. We can do it looks like it's all of them, and that was not found there. Access denied, access denied. It looks like none of them were successful, so we need to use a different file. And Unix users. users. Well, let's go and change. My password file. So I can just use a password, single password, or an actual password file. And this is not a guarantee. You know, your successor is going to be only as good as your dictionary. And the configuration of the intrusion detection and prevention, if you're only allowed 3 attempts, you may be locked out after those 3 attempts. Let's give it a try and see what happens. Incorrect, incorrect. So it's gonna go in and try to go through its magic. For the actual lab, I'll provide you with a specific dictionary file to help you out with the process and speed it up. Now, this again is going to be trial and error. Obviously the file that I used, I didn't specify correctly. So it looks like there should be the password is blank. How about this? Password is blank. So now if you notice here, what we're doing is we're using username and password. What if the password is blank? Say, look at this. Blank passwords. Yes. No password file. Let's go to username. Root. Let's see if this works. There you go. So what I was doing here is, it looks like you opened up another session. Let's see, sessions. You see what happened here is success with username root and no password. Sessions. Oh goodness. Let's see, sessions. Number 3, that was the back door. Number 2 was the back door. So in here, if I do interaction with MySQL, then no password. It looks like I cannot log in, but let's pull up here. And let's see, if we go into MySQL, the host, the password, 192.168.56.101, username, root, and the password. How about this? We're able to connect, so we're not able to connect from actually Armitage, but we can do it here. So show database, show table, show record. So show databases, and those are the available databases. Let's see, which is the one that we looked. Show tables. Let's see, MySQL. Oh, of course. MySQL syntax. Let's see, select O. from okay, so it looks like I set out my connection. Let's see, show databases. Try this again. Let's see, we need to use a database, and I have no idea which one, but we can try with MySQL. Database changed. Show tables. Okay, here we go. From user. From user. Select user password. Okay, so what I did here was I needed to connect to the MySQL database and then show the available, or the MySQL service, and then show the available databases. We're using the show databases and then the semicolon in the end. Those are the available databases. Each of these databases has tables. Each of the tables has records. The records can be the usernames in a specific column with the actual values, and then passwords. So I told it to use the MySQL table, and then I told it to use the MySQL database and then show the tables within the MySQL database. And then there was a table called users. So the table users, I told it to select all records from the table user. And then what we see is there is a record called user, and there is a record called password. So notice their user uppercase, password. So what happens when I tell it show, or no, select user password from user. There you go. So select uppercase user, comma, password from user, semicolon, and then I have, those are the available usernames, so root and guest, Debian, sysmaintenance, and they have no passwords. Now use Metasploit. Okay, database changed. Show tables. There's no tables there. Alright. Show databases. Alright, look at this TikiWiki. TikiWiki. Use TikiWiki. Okay, show. Oh, I too quickly Control C to enter, so now I gotta redo. Use TikiWiki. Show tables. So these are the available tables within the database TikiWiki. So obviously we're looking for things like username. And there's user tasks, Tiki users, from Tiki users. There's nothing. How about from users? And there you go. So you have user ID and password. User ID and password. So select user ID, password from users. User ID 1, password. Man, that's not probably what I wanted. Let's do user ID. I want to log in and password. There we go. Admin. How did I come up with this? Those are the available columns, I guess. User ID, email, login, password, provision password, default group, last login, and so on. So now with this TikiWiki, if I recall, it was an actual service, TikiWiki. So if we do Tiki, what is it? Control F. TikiWiki. It looks like Tomcat. It looks like TikiWiki may be part of a different service. On top of Metasploitable, there is then vulnerable web application, which is vulnerable web applications. It may not be an actual service on the Metasploitable. It could be a post service on port 80 that needs to be started in order for to take advantage of it. I didn't see TikiWiki running, but it also possible it's on a different port that we don't see. So anyway, that was the MySQL. So in addition to this, what you can do is there's an easy VNC exploit, and then there's a Java RMI server exploit. The Ruby one, I think I need to work on the redoing the exploit, because you're going to be able to successfully launch it, but no shell is going to be open. And then if you look into, there's additional vulnerable services. There's the RPC service, NetBIOS on 137, and NFS, which is file sharing. So that's kind of the methodology. I know this video is probably longer than I anticipated, but hopefully it was useful.